Hi, my name is Stefan and I'm a tech lead in the escalation team here at Imperva. We frequently get tickets where there is a problem with a WAF gateway, and when we do the investigation we find that it is due to resource exhaustion on the gateway. This raises some questions for many of our customers when they look at the datasheet for their specific WAF gateway device and see that it is rated to a specific throughput expressed in terms of gigabits per second. They say they're not pushing that level of traffic through the gateway, so how could it possibly be out of resources? The purpose of this video is to explain to you why that may be the case and what you can do to resolve the issue. The first point that should be made is that resource exhaustion isn't only network throughput. There are three specific items which could be exhausted, three different kinds of resources. Firstly, CPU. Secondly, memory. Thirdly, network throughput. It's important to note that on the data sheets, when it says that the throughput can be up to a specific level, that should be taken as a maximum value. The reason for this is that the tests done to establish these maximum values are done with a very specific traffic profile under very specific test conditions. Because most people's actual traffic profile doesn't fit these very narrowly defined situations, what you have is, in real life, traffic volumes or traffic throughputs that will be lower than the maximum noted on the datasheet. So let's talk about some of these in a little bit more detail. And we'll go in reverse order. We'll talk about network first. It's rare that the throughput on a pure network level ever gets to the level that the interface cards can't deal with. However, there are times when you can see that the network of the box is in fact the bottleneck. One of these cases might be in terms of sockets. Because the gateway boxes have an operating system, there are limits to the number of sockets that are available to the network. What that means is if you're running a mode such as a reverse proxy mode where you have more individual TCP sessions at any one time, and if your traffic profile means that those sessions are open for a very long time instead of there being very short-lived sessions, you could hit a situation where you simply run out of sockets. At that point, the box may not pass traffic and you end up with a service affecting situation. The way to fix this is simply to have more gateway devices so that you don't hit the limit of the number of sockets. Another case where you may hit a limitation in terms of network is if you're passing all your traffic through the gateway, even if some of it may not be inspected. This is sometimes the case in bridge deployments where all traffic of a specific leg is sent through the gateway. If not all of it needs to be inspected, all of it does still use resources because it has to be handled. Therefore, a recommendation in this case is only pass traffic through the gateway that needs to be inspected, or perhaps traffic where the response to the requests may need to be inspected. Anything that doesn't need to be inspected shouldn't pass through the gateway. The second point is memory exhaustion. You may find that there are specific modes of working that use up more memory. For example, if you are using a reverse proxy mode, whether it be kernel reverse proxy or NGRP, or transparent proxy or advanced bridging, you may find that because you have double the number of TCP connections, you need more memory. If the traffic you're inspecting is also made up of very large posts or very large requests, then those will take up more memory to be handled with. Each of them has to be assigned a block of memory. If those then include things like XML files or JSON files, where there may be nested arrays, each of those arrays needs to be unpacked, and each of those unpacking will use more memory. That's why, although you may not be hitting the throughput limit on the specification sheet, you may find that you are actually running out of memory, simply because the type of traffic that you're looking at requires more memory to be parsed. In this case, It may be possible to tune the type of policies that are applied against your traffic to avoid this. But in general, you will need to perhaps increase the size of your gateway as well. Then we come to the third and by far the most common cause of gateway resource exhaustion, that of CPU use. Because the gateway is a computer, it uses CPU for every packet it processes. And if you're running, for example, in a reverse proxy mode, every request that that gateway needs to parse results in 2 different TCP sessions. It also may have 2 separate TLS sessions to build, and that becomes expensive in terms of CPU use. Adding in security policies which make heavy use of regexes in terms of signatures of known threats, regex comparisons are CPU intensive. They use a lot of CPU resources. And doing this over against large requests as opposed to small requests will increase that CPU usage even further. What that means is that the type of traffic, whether they are small requests or large requests, whether you're talking about a reverse proxy mode or a bridge mode, and even whether you want to inspect the data coming back from your web server, all of those will make a difference to the amount of CPU your gateway needs to handle the traffic you put through it. Also, the type of CPU usage makes a difference. There may be CPU used by the kernel, or there may be CPU used by user space processes. And a system which has high kernel CPU use will act differently to a system which has very high user space CPU use. So if you're running in user space, for example using advanced bridge mode or NGRP, you will see different results from high CPU use than you would if you're running in a kernel-based mode, such as kernel reverse proxy. What this means is that there's not one answer on how to reduce CPU usage, but there are some general guidelines. For example, only apply security policies that need to be applied. If you're not running a WordPress server, there's no point applying all the WordPress specific signatures. Also, only look at responses if you're expecting something specific to be sent back to the clients. For the majority of traffic, the responses don't need to be inspected. So in that case, there's no point defining a security policy to inspect those. Finally, look at the way in which your system is deployed, whether you're using an advanced bridge or an NGRP, and tuning it to the requirements of your specific traffic profile will make a difference. We've just looked very quickly at some of the things which can cause resource exhaustion on your gateway. We've by no means covered them all. But the point is that when you raise a case with support and support tells you your gateway is suffering from resource exhaustion, you hopefully will have a slightly better understanding of why that may be the case, even if you're not hitting the headline traffic throughput on the data sheet. What support will do is explain to you why you're running out of the specific resource that is causing a problem. And remember, it may only be one of those 3 that is causing a problem, but that still means that the entire gateway is suffering from resource exhaustion. But support will explain to you why you're suffering from this resource exhaustion. They'll explain what data brings us to that conclusion and will offer some suggestions on how you could mitigate it. When we tell you your gateway is suffering from resource exhaustion, what we want to help you do is to see value from your investment. And sometimes that may mean some additional investment, but you can be sure that we will back up everything we say with the data you've given us. So if we ask you for information, if we give you an explanation, please be assured that we're trying to help you to get value from your WAF gateway.